Hello. What we're going to look at now is maximum and minimum problems, or max-min problems. These often involve English type stories. Sometimes they'll be real life situations. Sometimes they will be more function-based type questions, but often the maths will not be the most challenging part. The differentiation will be the most challenging part. It'll be interpreting the story that we are given. So let's jump into a question. As a general guideline, we know that maximum and minimum are dy dx is equal to 0, d2y dx squared is less than 0 for a maximum. We always do that second derivative test, and for a minimum it's where d2y dx squared is going to be positive when dy dx is 0. So we already know that, and as a general guideline, we want to write the functions that they give us in one variable. Most of the more complicated versions of these questions will involve situations where we have functions given to us with more than one variable, and we need to do some substitution to get them as one variable, because in Leaving Cert we only do differentiation with one variable. Sort of. With related rates of change we kind of touch on other situations, but for practical purposes we just get functions in one variable. And the other huge piece of advice is, if you can draw any kind of a sketch to give yourself a visual anchor for what's going on, we draw that sketch. Every time we take the time to get good at it, so that in the exam, if we get stuck, we have a pictorial reference to figure out what they might want from us. So let's dive into this question. If the profit of a company is modeled by P is equal to this, where N is the number of products made, what is the maximum possible profit according to this model? So there's not a huge amount of sketching I can do here, and I already have the function in one variable. Profit is the function I am dealing with, and it's in terms of one variable, which is N, the number of products I'm making. But I can still draw a sketch, because this is a function, and I could draw a very quick, crude sketch for myself. If I have profit going here as my y-axis, a function output, and N being my number of products made, and this is in euro, I have my function is a negative quadratic. So a negative quadratic is a frowny face. So I know that I have a frowny face type curve, and I am looking for the maximum profit. So maximum means largest, and profit is measured on my y-axis. So I am looking for this point here. I am looking for the maximum of that curve. And now I have a visual reference. I have more of an anchor as to what this might mean. There's a lot of English in this question, and some of the exam questions are even worse. Now I have a visual understanding of what type of question am I dealing with? And this gives me the confidence to move forward. And it's not a minor step. It's really important we do this. So what are we looking for if we translate this into mathematical language? What is the maximum profit? Well, where's the maximum profit going to happen? Well, a maximum is going to happen where the PDN, the profit as the number of products changes, will be equal to 0, and d2p, dn squared, is going to be less than 0. That's what we're looking for, and we're looking for the profit when this is true. So what is P equal to when that is true? And I need to be careful that it's what P is equal to, what the profit is when this is true, that I am looking for. So let's get into our question. I want P is equal to minus n squared plus 700n minus 60,000. That's 4 zeros. dpdn, dn even, is only minus 2n plus 700. And I want to know what value of n makes that equal to 0. When I rearrange that, I'm going to get n is equal to 350. Now my job is not done. I need to know whether that's a maximum or a minimum. And I also note that this is what I've just found is the number of products I should make in order to maximize my profit, which isn't what I was asked for. I need to find my profit at this point. So let's double check that we have a maximum, and then let's find our profit. Double check that let's find our profit after that. So double checking that we have a maximum. I want to find out what the second derivative is. This is my first derivative. If I get the derivative again, I get -2. Therefore, or my second derivative at n is equal to 350. Well, there's nothing I can sub in there. It's just equal to -2, which is less than 0. Therefore, I have a maximum. So I have found a maximum because my second derivative is negative at the point I'm interested in. Now, we know that a negative quadratic can only have a maximum. There is only a local maximum that can occur there, but we still have to do our check to make sure that we get all of those marks. So now I know that I have a maximum, and I know the number of products I should make in order to maximize my profit. Now I have to go back to my profit function, and I have to sub in my value for n. So this is p in terms of n. So I'm going to have -350 plus 700 on 350 minus 6,000. When I put that in my calculator, I get 62,500. So when I make my 350 products, I am maximizing my profit, and that is giving me my, and now I've subbed that into my profit formula to find out what my maximum profit would be. Now, they don't do this as much on the exams anymore, but I'm going to highlight this to you because it has historically been important. If you can visualize why this would physically be happening, if we start making only a small number of products, we aren't breaking even yet. It costs us more to make the products than we are making them when we make small numbers. At a certain point, it becomes profitable. We're making enough stuff that we start to make a profit. At a certain point, demand will meet supply, and we will end up maximizing profit. If we keep making more and more stuff after that point, we'll be flooding the market, and we won't be able to get as high a price for our product, and therefore we are not going to end up making as much profit overall. This is not necessarily always true. There are different ways of modeling products, and those of you who do business and so on will have a much deeper understanding of it. But this is a argument for why you would end up with such a model for profit. And it's important you have a little bit of intuition as to why that would work the way that it does. Now, next example I'm going to write in here. Now, the volume of a cylinder is 36 pi, and first job, show that the surface area of the cylinder is given by this formula, and then find the minimum surface area, min SA, minimum surface area. So now we're really into applying our advice that I gave you earlier. What's the first thing I'm going to do? I'm going to draw a diagram. So a cylinder is a circle on the top, a circle on the bottom. I note in all of my different shapes. This is going to be OR, this is going to be H. I know that the surface area is going to be the area of the top surface and the bottom surface plus the area of the wrapper. If we imagine this was a bean tin, what's the surface area of the wrapper going all the way around? Well, I know that if I cut off the wrapper, it would make a rectangular sheet that would have a length around of my circumference of my circle, of my top piece, and it would have a height of H. So my surface area is going to be, my total surface area is going to be 2 of my circles, my top and my bottom, so 2 pi r squares, that's my top and bottom, plus the area of my wrapper, which is going to be 2 pi r h. and that is my, oh dear, pardon, yes, that is my surface area. So this is what I'm going to do first. Draw my diagram, see what I'm able to figure out. Then I go and see, well, what do I have to end up with here? I don't actually see a H in what I'm asked for, but I have a H obviously in what I've got so far. So what information can I use to get my H in terms of R? Well, I'm told that the volume of the cylinder is 36 pi. So the volume of a cylinder, I go to my log tables, or I can look at it visually, is going to be pi r squared times h. Pi r squared h is the volume of my cylinder. And then I know that the volume is 36 pi is equal to pi on r squared on h. Rearranging, divide both sides by pi r squared, and I end up with 36 all over r squared. I can sub that in here, and let's see if I get what I was looking for. So the surface area is equal to 2 pi r squared plus 2 pi r on 36 all over r squared. So the surface area is equal to 2 pi r squared plus 72 pi all over r. And lo and behold, that is what I was asked for. Now I'm asked to find the minimum surface area. Well, I know the minimum. I have to get the SADR and then set that equal to 0 and check that it is a minimum. So the minimum of the surface area is the SA. You can put it in brackets if you like. dr is our variable. I need to change that into my power notation, which I think I'm actually just going to do here. And then I am going to get 4 pi r minus 72 pi r to the minus 2, and I want to know when that is equal to 0. So I need to multiply both sides. I recognize that I have a negative power here. I don't like that. So I'm going to try and solve this by multiplying both sides by r squared. Both sides of my equation by r squared. And I will end up with 4 pi r cubed minus 72 pi is equal to 0. Rearranging, I'll get r cubed is equal to 18. So r is equal to the cube root of that, cube root of both sides. You can just leave it as the cube root of 18 if you like. If they ask you for an answer to a particular number of decimal places, you can also leave it to that. 6207. Now I need to check whether that's a maximum or a minimum. So I need to check if d2SA dr squared, what is that equal to when r is equal to cube root of 18. So I go back up to this and get the derivative again. So I get 4 pi plus 144 pi r to the minus 3. And I want to know what that is equal to. That works out to 12 pi, which is greater than 0, therefore a minimum. So we sub that value of r back into our surface area formula that we worked out up here, and we get 129.46 units squared. And that's what we